How I unmirror it? Oh. Right there. It's all done. Yes. I'll be talking about WebAssembly. And of course, I start building some demo. So I'll not be cheating. I'll just remove all my WebAssembly files. I hope I don't have any. But anyway, so I gave a talk not long ago, I think probably a year and a half, about WebAssembly. It was new. Everybody didn't know what to do with it at the moment. Now it's more mature. People start using it in some unusual scenarios. What's WebAssembly? It is format, and this format will be executed on some virtual machine. And this virtual machine is nowadays supplied with every web browser, and it comes as a standard and attached to every JavaScript engine as well. As developer, you will not see much WebAssembly, and at the best, what the developer can do is type something like that, which will be one function and some low-level operator, which pretty much, in this case, just simple 42 number. So that's not what WebAssembly engine will consume. It will use binary format. And there are tools that will convert text format into binary format. So it will, as humans, we will not be able to read it efficiently. Of course, you can go and start decoding it, but there is. T.wat is just text representation of that binary format. So there is there is some influences from Clojure, but there is no direct relation. It's just format that was just built just to display binary WebAssembly format. So, as I said, most of JavaScript engines already have WebAssembly engines embedded in them. So, and for example, you can use Node to load that file. Here we will try to load our binary file. So, and inside of JavaScript, every JavaScript engine supplies JavaScript API where you can load and execute WebAssembly files. In this case, we will instantiate WebAssembly code inside of JavaScript engine. And inside of my example, I just created one function that will be called as a test. And right here, we can execute this function. Here you go. Node can execute any WebAssembly code you can create. So, but again, it's WebAssembly. Nobody will be typing WebAssembly code manually. So I demonstrated that C was some capabilities of generating WebAssembly. And there is some capabilities in Rust, and they got better. So I can type same code in Rust, and I can compile that code in Rust directly to WebAssembly. So every Rust compiler supplies WASM32 target, where you can use an output. I'll do optimized, but since it's not standard executable, it's a library, we have to specify just that. Here you go. We can see what Rust generated for us. It generated WebAssembly code. We're looking at its text representation. And let's look at our function. And our function just returns constant 2018. We can go to Node again and execute that, or we can use it's in normal environment, which is web browser. So instantiating and running will look almost exactly like it will be in Node. So all you have to do, you have to instantiate, you have to start fetching binary WebAssembly file, use instantiate or instantiate streaming to create instance, and then you can just invoke test method. So right now I was using t.wasm file, but I just created Rust version of it with similar interface, which has test method. So if I'll change file name, it just executes Rust code. So that's simple it is. So people realize that it can be used in operating system natively, not within web browsers. And there was a period demand for system calls. So
I'm sorry. The WebAssembly file that you called async and you pulled in, can it talk to the parent JavaScript instance, or is it like siloed? I see that it's in a closure, right? But can they?
Yeah, I didn't show that, but every WebAssembly instance can import some stuff which can be JavaScript methods. It can be some primitive globals like integers. So yes, if
so that's the right way to do it.
Some function, WebAssembly can call it, and this function can be either JavaScript or it can be even WebAssembly from other module, WebAssembly module.
Awesome. Would that affect its performance if it's importing things from the?
It was an issue in the past, but most of vendors now trying to resolve it, and it's fast now.
Sorry to interrupt. I'm sure other people were thinking that. Thanks for answering.
Okay. Everybody knows that Hello World is a simple application that anybody can write, but problem is it comes with really huge price. What it needs to do, it needs to open operating system handles, call some syscalls to make sure some characters going back and forward, some buffering status, get some arguments from command line, all that interesting stuff. That's why there was a period demand for WASI, which stands for WebAssembly system interface, which exactly what you're talking about. It's some external dependencies that needs to be imported into your code. So let's compile hello.rust and try to execute it natively without web browser and see some meaningful output, not just 42. So compile, but this time we will use different target. We will use and you noticed I didn't try to force it to compile it as a library. It compiled as an executable. So which, if I'll try to display, let's see what's inside of that. So program becomes really complicated. It starts importing functions, and in this case you can find that it's trying to import functions from command line tools that would be assist with getting environment or arguments, and also primitive function to write stuff back to operating system. And you can see start method got more complicated. You can see some branching, some meaningful logic right there. I'm sure we can find main function somewhere. That's our main function. And as you would expect, it would just do. Okay. Now question, what can execute those stuff, that binary file? It would not be web browser. It might be Node if it has the right, if it will supply the right imports to it. People start binding WebAssembly engines with, make standalone WebAssembly engines and supply those WASI interfaces to it. One of them is WASM time, which I'm working on. So what you can do, you can just directly supply WebAssembly binary. It will compile to native code and execute it. So you would see it as you would see it running as normal executable an operating system. That's when you hear Docker talking about security and stuff, and they're saying if they would have that technology, it would be way easier for them. But again, it just theoretically. But what does it mean? It means that you can just create one binary and it will run on any operating system in any environment, and it will be somewhat secure. Unless you provide some unsafe import to it to manipulate. It's all good, but now we have. You can see that WebAssembly interface is primitive. What it can accept and pass around is just integers and floats, and it can also provide its memory to be consumed. There is no strings, there is no object that JavaScript can provide. So how JavaScript would efficiently communicate between WebAssembly code and JavaScript. So you cannot just create object and pass it to WebAssembly, and WebAssembly cannot create string and give it to JavaScript. So it all complicates things, and people working for a long time to solve that issue, and they come up with other different solutions. And one of the solutions was to use WebAssembly bindings. You can see lots of noise about WebAssembly bindings, but it became, at this moment, it has name type type interfaces.
So what happens if you go back to your t.wat file, or I guess your Rust file, go to the t.rs file. If you, I guess any of these, but what happens if you, if like test takes an argument and then you call that in JavaScript, you can pass, I'm assuming you can pass it strings or integers or whatever, will it convert them? Because you did talk about conversion. I'm wondering if you're talking about just the importing or arguments.
Yeah, and so question is, what if I'll just provide here something with just 32-bit integer? It would be simple for WebAssembly to consume. But if I start providing something like string, you would have problem here. WebAssembly doesn't know how to operate with that stuff. That's exact problem I'm trying to formulate, and eventually you would want to write code something like that. So you would want pass name as a string, and JavaScript will pass that name as a string. You would not care about taking that presentation and make it in binary form. Also, you want to receive data in meaningful way. You want to get string versus some binary blob of data and then start converting. So that simple project, that code, just what it does, it just gets name as a string. That would be pointer to string characters in Rust, and returns string as a created object. So things getting more complicated at this point. You need some other tools assistance. So in addition to Rust code, in this case Rust, it can be other language. You have to provide additional post-processing of your WebAssembly to create a layer that would do transformation between memory and primitives into JavaScript objects, which in this case WebAssembly bindings, or in WASM pack, which is a Rust tool system, can do that. Can do that transformation. So there is a tool, WASM pack. Sorry, it's too many confusing names. So what this tool does, it will compile Rust code and use its metadata to generate JavaScript proxies that would just convert types like strings. So, and I'll just start using experimental feature, which is type interfaces. But you can call it without that. What it will do, it will compile your Rust code into JavaScript package. You can just publish into NPM. And this package, what it will do, it will provide additional tools in JavaScript that would take memory representations of strings, package it into strings, or other way around. So it will convert strings into memory and provide to your WASM code.
All your samples here tend to be Rust-oriented, and I've seen a lot of Rust interop with WASM.
It's easier with Rust.
Is it like, how is the ecosystem for other languages? Like, are people working on C++?
They're working, but it's not something to demonstrate at this moment. And spec is in the process at this moment. Specification. So, but you can take Rust and you can connect with some C code if you would like to do that. So you can kind of create proxy, and Rust is capable of compiling C code. What you would do, you would just create that proxy in Rust. That's all you would do. So how would I use that package that I just created? It's JavaScript package. I can publish into NPM. And I'll do it in normal way. So I'll just create my and bind use package. I'll add my bind as a dependency. Install. I guess I already did it, but I'll do it anyway. Let's see. Yeah, I already did it. So I added as dependency, and I'll wrote some code. This code doesn't look any different than you would write in JavaScript. It would just instantiate module, which is my bind, and it would call greet function that we just wrote in Rust. So it's greet function, hello world. So you would need also additional tooling to convert dependencies on the fly, which will be translated into JavaScript. So you have to provide loader for Webpack. In this case, I'll be using Webpack. Sorry, Webpack. What it will do, it will just transform WebAssembly and JavaScript and package as a final solution. Let's see. So after running that, and try to run it. So you would, of course, you would see hello OKC. Since I provided as an argument to our greet function. So it's at this moment it's pretty much straightforward for JavaScript developers to use and consume those modules. Only problems will be to creating that proxy layer, which will be taken care of Webpack tool, WASM pack tool, not Webpack. And I guess that's it. Thank you.